Hello and welcome to Inform Friday. I'm Lila Angelaka and I work for Historic Environment Scotland in the technical research team. If you're new to this, we've done quite a few of them. This is a series of discussions about traditional buildings, and we are presenting a short topic each time, and then it's followed by a live Q&A. If we don't usually manage to answer all questions, we get back to you asking us to email us. The point is also to introduce you to our Inform Guide series. So each session is corresponding to one or more of our Inform Guides or other published guides. The Inform Guide series are short publications which are giving technical advice for homeowners, and they cover the basics on a number of topics. So we are starting a spring series with the long-awaited session on solid walls and their insulation. Many of you have also asked questions in the past about lime mortars, which we'll try to cover briefly today, but it's a whole topic on its own. So if we don't manage to do that today, and if there's a lot of demand, we will try to do another session. So solid walls is the last main element of a traditional building that we wanted to address, since we already talked about roofs, floors, and windows in the past, amongst other things. And also, my colleagues are going to put some links in the chat from our former Inform Fridays, which are also all recorded and available to watch afterwards. A note here also to say that we will be covering damp issues in our Inform Friday session in May. So we'll only touch on that quite briefly, because again, walls is quite a big subject. If you have any questions relating to damp, we might wait until the next session or ask you to email us separately. So as usual, if you would like to ask us a question, although we've received quite a lot for this session already, you can email us. Or you can put a comment in our Facebook page or log into your YouTube channel with your Google account. As I said, all the events are recorded and available to watch. If you'd like to email us, you can email technicalresearch@hes.scot. So, as usual, I'm gonna introduce you to Roger in a few minutes. Hi, Roger. He's already here. So we will try to cover the basics on solid mass masonry walls today. Again, we don't have time to cover all types of walls. So we will discuss about how they're built, what materials are used, how they perform, as well as various repair and maintenance issues. We will, of course, also touch on installation options, but please be aware that we might not be able to manage everything today. And there's also another live stream called Energy Efficiency in Older Buildings, which is available to watch on the Inform Friday series. And if there's a lot of demand, we will try to do another session. So Roger will start now with how mass masonry walls are made and how they function.
Right. Hi. Thank you, Leela, and welcome all for our next this new series of Inform Fridays. So mass walls then, quite very popular and common in Scotland, quite often 600 mil thick or so, generally lime bonded with a lime mortar, or often a lot of Scotland has clay mortar in the core of the wall. This image here has got Holyrood Park Lodge, which is perhaps the sort of the upper end of the masonry spectrum, with essentially an ashlar wall where your masonry units are cut neatly into Lego blocks. And the next image shows probably the sort of the top end of the masonry with a very formal. This is actually quite new, quite modern work. In fact, that droving is almost definitely been done by machine, but it shows you ashlar joints, very fine joints, very high quality work, which is often some medieval buildings featured this as well, obviously with not quite the same level of machine finish. What's probably a lot more common though to most folk around Scotland is what we might call the rubble type approach, the coursed rubble here, where you've got a fairly coursed layering of the masonry. This may well have had a slightly different pointing finish, but you get the feeling it's a mixture of masonry units. Some of them are slightly squared, and then bits in between. And I think we should remember that in Scotland, mostly, a lot of these buildings had a render cover. This is a refurbishment project we did up in Shetland with an owner here, where that was absolutely soaking wet, and we helped them reinstate the traditional harl, and it's now a whole lot drier than it was. So generally in Scotland, the rubble masonry was covered up to give a more formal architectural finish, and most importantly, to keep the rain out. And that specifically means the render and the lime wash that goes on top of it. In terms of what does the wall look like inside, we've got a couple of cut-through images here to give you a feeling for the wall. So my friend John Gilbert drew this up for us. So you've got the outer skin to the left, you've got the wall core in the middle, and then generally the inner face of the wall is quite often made of much smaller pieces. The rubble work is slightly more thrown together, and then you may have a lath and plaster lining, as we've got shown here, or indeed on the next image you've got plastered directly on the hard. On this image also it's showing an external render or plaster, which quite often was lined out actually in imitation of ashlar work. And this system works pretty well. These walls should be dry, and when they're not dry and they're damp for various reasons, it's normally a defect or what someone has done in terms of materials, and we'll touch on how those materials can affect things. So my next picture gives a look at the vapor movement through a wall, how it handles moisture, and much of the trouble with older buildings and damp is a breakup of this moisture dynamic. So on the right hand side we've got the face of the wall, and I've shown it's a pointed wall there, with the rain coming in, a little degree of penetration, sun comes out, that evaporates away, and then ditto on the inside face. I've got it plastered on the hard there, but actually a lot of you will probably have maybe lath and plaster walls, or indeed plasterboard now. So ensuring that vapor open dynamic continues, in my view, is the sort of the key to the health of your wall. And if your wall is dry, it'll feel dry, it won't smell damp, and equally importantly, it won't conduct heat. It'll conduct heat. It'll hold heat much better. It can't conduct heat away quite so much. We've got a couple of later pictures that talk about the base of a wall, but what we call this is sometimes called breathability or vapor movement, and really getting that bit right is the key to the health of your wall, and certainly something you should be looking at quite hard before you consider energy efficiency measures and how they fit in. I think in recent years we've got more showering, more washing. We perhaps spend more time indoors, so the vapor build up in homes is probably a lot more than it used to be. And actually we're not so good at ventilating now. We've been encouraged to make things very airtight, which is fine at one level for certain aspects of energy efficiency, but can lead to unhealthy conditions and things. So the next slide then looks at the lath and plaster lining, and some of the notes on the image there give you a feeling for the pathways of moisture. And I think something that's only recently been appreciated is if you have a very flush point or a lime render, you've got a very high evaporating area to take the vapor out of the wall, depending on your stone type. Some stone types are very hard, that don't shift any vapor at all, such as granite. Some, like the red sandstones down in the southwest of Scotland, they're fairly open structured and can shift vapor. I think we probably need to consider various types of mortar now. So you've got the lime mortar, probably built with a quicklime mortar, very vapor open and capillary active. And then later materials, natural hydraulic limes and cements, don't shift water vapor, are not so capillary active. And this is what tends to lead to the trouble with getting water and moisture and damp trapped behind layers of cement and cement-based render. This image here shows some quite sort of degraded sandstone and little bits of cement adhering, and then the whiter lime. There is, of course, a stone quality consideration. Stone sometimes is just not that good from perhaps the higher end of the quarry. And this is probably a combination of poor repair or lack of repair, a bit of random cement work, not very well done, and possibly a poor quality stone as well. In the next image, I've got a sort of slightly stylized view of defects on a gable. And there was a few years ago, we had some very intense rain over a very concentrated couple of months. And we got a lot of phone calls from homeowners with wet chimneys, wet gables. And this prompted me to do a very cheap and cheerful sketch here with the right-hand side looking at showing the defective elements and what could be going wrong. And then on the other side, the right-hand side, how you could ensure your maintenance was up to speed, and maybe some additional detailing. And I call this, in summary, climate change adaptation. Scotland has more rain now than we did since 1945 or so, and the climate change predictions suggest that we are going to get more intense rainfall over longer periods, particularly in the summer. So again, don't feel you have to read this now. I'm moving very quickly, I know, but maybe after this, go back to the stream, which you can look at remotely again in your own time, and perhaps have a read through some of this. The detail of all this is contained in Short Guide 11, which is climate change adaptation for traditional buildings, where this is described in a bit more detail. Okay, so let's say we get this really wrong, and we really don't look after our wall, we don't look after our rainwater goods. What's going to happen? And ultimately, you will get structural movement and potentially structural failure. So the next image shows the picture of a wall that's starting to distort and move as the binder, the lime, the stuff that holds it together, is washed out. Frost action and the breaking down of the mortar means that you can get movement. I was at out in Glasgow yesterday looking at a couple of tenements where the downpipes on the back had been running water down the face of that building for years, 10, 15 years, and the walls were starting to bulge really quite a lot. This is an exaggerated diagram, but it proves the point, I'd hope. And then on the inside, you start to get issues with your timber due to internal dampness as well. So just to reinforce that about the maintenance and durability, if you keep walls dry, they will last for an incredibly long time. I go to ruins in the place where the walls are able to breathe, even with no roof, and they're absolutely fine. But if you concentrate water running off somewhere into one place over an extended period of time, you will get structural problems. Now, I'm just slightly conscious of time, so I'll just kind of move quickly on a couple of defect areas that you can see. So my next slide shows some spalling render where you've got rising damp, probably a defective drain, poorly ventilated area, and possibly even a rising ground level with this is lime mortar as it happens that's spalling off. And then the next picture shows the effect on the inside of a building where you're starting to see the damp coming through, and then the white efflorescence, which is always the boundary, the drying area, the drying boundary of the let's call it the boundary between the wet bit and the dry bit where the salts crystallize, and also the timber inside where it is subjected to this level of saturation will start to rot and decay. So these are situations that you can easily avoid by getting the right materials and the right maintenance regime. In this particular image, it's all looking quite grey, isn't it? And that's not just the masonry. It's also, there's a lot of cement which has been put in there as an attempt to sort of somehow hold it back, which of course is not actually helping at all. It's preventing the wall from drying out yet more, holding it in and causing the timber to start decaying. So there's a next couple of pictures indicating other areas of water stress or water loading. I mentioned here's a blocked down pipe. It has been cured actually, and you can tell that because the moss that is down there by the dog bowl is now drying off and brown, but you will see the legacy of the saturation around it in that kind of semicircular plume, and you'll see the white efflorescence. So sort out the problem and the wall will dry out again, as this indeed has done. So to some extent, a good news story there. So moving on then, yes, and of course here, You can see the puddle at the base of this church. This is a building in Govan, actually, and increasing rainfall will also mean that the water table is higher than it perhaps was before. So you may have to think about adjacent drainage, getting that water level right down. If any building has its feet in the water like that, it'll be damp, and as we know, lime mortars and other things draw it up. Here's a pretty scary picture of a small tree getting stuck in on a hopperhead behind a parapet gutter. All sorts of things going wrong there, and you can see the discoloration on the stone on the building on the left, where that's now utterly saturated. Now, just a few pictures to follow for sort of lookings at lime mortars and cements. So here is probably a late 19th century wall of a sort of coursed rubble or sawn rubble that's been pointed up in cement in the past, and you can tell that's blocked the movement of the water in the wall, and that's put quite a lot of stress on the stone, causing it to actually start to break down. The next picture then is just picking up on this theme of stone maintenance and how you look after things, and this is stone cleaning actually. On the middle left of the image, you've got the darkness of the unclean stone tenement, and then on the middle main image here, you've got the stone cleaned element, which looks very white and bright and shiny. But stone cleaning really shouldn't be done, really, unless as a last resort, as essentially it's accelerated weathering. So probably just hold back on stone cleaning if you can. It's also fairly expensive, and we'd far prefer people spent it on the maintenance of the roof, the gutters, the downpipes, and that sort of thing. So repair mortars and structural movement and things, you may also have a degree of settlement in your building. So here we have a crack that has been filled in once before already, and the main thing with this sort of consideration is, why is that masonry settling? It would appear you have an area of settlement off to the bottom left there, and therefore it's opening up. Why is that happening? Dealing with the crack itself, the filling, is actually relatively straightforward, but you need to understand why that's happening. Is it legacy? Has it stopped, or is it actually ongoing? So I think that's just really a situation to get a consulting engineer in or something like that. So look for professional advice if you get this situation on your particular building. And I should probably also talk about repair mortars and things that go with that. You can face up stones with stone repair mortars, but it's something to be looked at quite carefully. And generally, we prefer restoration mortars, repair mortars, to be used only in very, very specific areas, and not necessarily the entire covering of stones. If that is the case, maybe you're looking at an entire stone replacement, sometimes called an indent, and we've got a masonry repair guide on that as well going forward. So that was a real quick canter, and I'm probably a bit behind time on masonry stuff. Very happy to take questions and things going forward, and I think we're now at the insulation stage now. So over to Leela now for a canter through that one too, please.
No, you're fine. We just had a thought because we received quite a few questions on repair, so we'll go a little bit and run through them, and then I'll talk about insulation. So we had a question from Steve, who asked how can he tell what kind of mortar is used on his home.
Right, there we are. What kind of mortar? No, good question. Generally, cement mortars are quite grey in appearance. They're certainly quite hard. If you have a piece like this and you try and break it, you probably won't be able to. You could also dip that piece of mortar in water and see if it draws moisture up through it. If that capillary line doesn't move, it's probably cement. Also, if you tap it, it can have quite a hard, ringy sound, or try pushing a bradawl or a screwdriver into the mortar and see how far it goes in. A lime mortar will be an off-white cream color, and has actually quite a lot of give in it.
Another question from Wells on Facebook. I'm just going to summarize it, but basically they removed their cement render to do lime render, and they're asking about permeable chemical to keep it dry, and they're asking to also keep it from staining.
Right, there's clearly, actually I've just seen that on the chat there. So you've taken off the cement render to reline that. Yeah, well, I would be doing a new lime render on that one. Do we need to coat it with a permeable chemical? No, I wouldn't do that. I couldn't advise on that at all. And it also looks like you've got a second issue of staining on your lath and plaster inside. That suggests you've got a bit of saturation on the inside face, which probably means you've got a leaky chimney and you've got actually liquid water on your inside face. So this is not about the bridging of the lath and plaster, which kind of happens. It's about getting the wall right. And it may be in dealing with the cement issue that you might have sorted that out with the moisture now able to breathe out from the walls. But I would suggest a proper covering back on that rubble. Exposed masonry is a leaky thing, and I'd suggest you get something on there, perhaps a flush point with lime or a lime wash or even a new lime render.
Great. Next question, Debbie on Facebook. They have repointed in lime the stone outside and replaster in lime. However, they're getting patches of salting inside. Similar, I guess. How do they sort this and repair to repaint?
Right. That's interesting. So if you're getting the salting, the efflorescence, that white sort of material that I mentioned that you saw, that suggests that the water movement is still active. So I think you're probably looking at chimney copes and skew cope detailing. This is the top half of the wall. Again, it's very hard to say simply from your message there what that actually means. But well, I know what it means. It means there's liquid water active and it's coming out, evaporating. The good news is that your building fabric can lose the water. You need to now identify where it's actually coming from, which I suspect is chimney or skew copes. Again, look at short guide number 11, adaptation, which gives you a bit of breakdown on weak areas for buildings and water.
Great. Next question. Sorry, I'm going really fast because we are getting quite a lot of them. So Al on Facebook, during the heavy storms, the back basement of their house fills with water and the water sits quite high up. So how can they waterproof the lower portion of the external wall while respecting the historic building?
The back fills with water. How can we waterproof? You can't waterproof a traditional solid wall. You can try tanking it if you wish. There's companies who provide that. But essentially you have a swimming pool outside and a Scottish water drain capacity issue. I mean, that to some extent that is them damaging your property by the drains being insufficient. I guess this might be a bit of climate change there. I think this has to be addressed with the drainage. Tanking is an option, but it's not something I know much about. And really it just prevents the water from coming through the inside face. It doesn't stop it soaking the wall and causing all the issues that we mentioned.
Yes. Next question. Sorry.
Yeah, sorry. There's an energy question. Are we going to take that later? Are we? Is that the?
Yeah. I'm just grouping them, just dealing with the maintenance questions right now. So if we have an opinion on the rising dam debate, some say it's a myth. I mean, we could do a whole new talk on this.
Well, I think from my experience, where you put suboptimal conditions around a wall, you'll get a wet wall. If you have the base of the wall wet through poor drainage, if you cover the wall in impervious materials inside and out, you will get the capillary rise going up. The trick with a traditional wall is to let the water vapor leave the wall at a quicker rate than it's coming in through other sources. And obviously getting the garden and adjacent ground as dry as you can is the start of the journey. I don't think it's a myth. I think it does actually happen. There are perhaps different ideas about what you do about it and many different technical takes on it. Our informed guide on damp causes and causes and treatments, I think we call it, or causes and solutions, gives you a fairly basic, good introduction to that discussion.
Yes, we also got a question that came through an email. So they have an older house that has been covered with cement-based renders. Should this be taken off and rehardened in lime, or can it be left there? Is this different for granite buildings?
I think it varies on the context. I've lived in a house covered in cement, and it was absolutely fine. But I did work quite hard at making sure the inside face was ventilated properly, was breathing. I didn't have vinyl wallpaper. I had the solum of the floor properly vented, and the ground levels I actually reduced by, I got a mini digger in and took out 6 inches or so around the base of the house, and the cement sat there and it was fine. It depends if it's causing damage or if it's actually failing. And quite often the trouble with cement is once it starts cracking and you get the very fine cracks, which are very effective capillary draws. It also depends on your exposure as well, depending where you are and what sort of weather you get. But don't feel if you have cement on your building it's some sort of terrible evil and you've got to get it off. It's just what condition it is in. Is it causing trouble? Is it in good condition? But if it's got a fine network of hairline cracks, that's probably not a good thing, and you might wish to consider replacing that.
And we got another one from John over email that also talks about efflorescent on a plaster interior stone wall from 1724. And the plaster has yellow darkened in patches, revealing a polished beam embedded halfway through the wall behind the plaster. Its purpose, origin, and depth is unclear. So first question is, should they remove the beam? And the second question is about the efflorescence, how you treat that, which you've covered briefly.
Yeah, I mean, efflorescence is a sign of liquid water evaporating on a porous surface, leaving the salts behind. That's what you're seeing. So almost what you do on the inside is really conditional on what's the outside situation. Where's this water coming from? Is the ground higher than on the outside? Is there an impervious layer? Is the defective rainwater goods on the other side? So it's not so much what you do on the interior, it's how you look at the other side of it and where that moisture might be coming from. The yellow and darkening is probably salts in the wall. There could be flues close by. So the salts from combustion gases give you a purpley, quite often a yellow type staining, which might well be it. So you're not treating the efflorescence, you're treating and addressing the conditions behind it. And something tells me this might be a flue or a damp flue issue. Blocked up flues are quite often a problem because the flue gases are hygroscopic. They absorb moisture from the air, and that will leach through your wall. So look at the flues and what's behind it and how they're ventilated. Again, there's an informed guide on chimneys and flues.
Yeah, the question about the beam, I mean, we're happy to, if you want to send us an email with a photograph of that, maybe we can see actually how it looks like and advise. Well, we can't.
Yeah, timber work in wet walls is not a good thing.
But don't remove it if you don't know what it is. Another question by Stephen on Facebook. So in an SSR, should the surveyor point out where cement mortar has been used extensively on a sandstone building built in 1888? Cement will clearly change the pathology and breathability of the walls. So I guess the question is about if the surveyor should point out where the cement is used.
It depends what you're asking the surveyor to do. If you're asking them to do a sort of pathological analysis of the building with respect to how it's been repaired, is that a good repair? Is that a bad repair? I'd expect people to note it if it was causing an issue, but a standard survey probably won't get into the detail of the mortar pointing, particularly if it's, which may well be it's unlikely to be original. I suspect it's a later repair. And again, cement is not necessarily a bad, evil thing. It depends in what context is it causing damage, what condition it's in. But certainly an 1888 building probably almost definitely wouldn't have been built with cement, that's for sure.
Okay, thank you. Fiona on Facebook, she had a leak down pipe, had it fixed, but there are still bubbles on the inside wall. How long till it dries up?
Yes, good question. The fact that it's bubbling means that you've got an impervious paint, because that is the film of the paint moving with the pressure of the vapor behind. So I'd suggest the first thing is that you address the type of paint you've put on the wall. A solid wall, if it's completely wet, I suspect you're in the 12 months type time to dry out, maybe a little less. And let's remember, when these buildings were built, the mortar was wet, the walls were wet, the plaster was wet, and it all dried out quite happily. So they do have a capacity to dry out again. But again, if you have the, let's call it, the wrong sort of paint, inside and out, the wrong sort of mortar, that inhibits that drying out process. Sometimes that's not an issue, sometimes it is. I suggest that if it's bubbling still on the paint that you've perhaps put in as part of the remedial work, that there is still moisture in there, that's fine, that'll disperse. But you perhaps need to have a more a vapor open paint. Some clay paints now are very good at that. They're very, very, very open, but they're very durable and give a very nice finish internally.
Quick question from John on Facebook. Once the sandstone begins to break down, is there any way of stopping it, or do we have to take out the stone and replace it? They have an outside sandstone lintel that is eroding away.
If, as I said, sometimes stone comes in different qualities, different grades, different densities, and maybe that's just not a very good bit of stone from not a very good bit of the quarry. You can't really stop it as such. If it's modest, lime wash is a very good consolidator of sandstone and mortars, but it depends on how your house is presented. You may not want to do that. And if it's more than 25% of its thickness, generally most would suggest that you actually replace that particularly if it's a lintel over a door or something like that.
Right. We had a similar question on it, so I'm not going to cover that one. But there's a last question, and then I will have to talk about energy efficiency because we are running out of time. So they're in Edinburgh in a garden flat, and there is a wall, high stone walls with ivy growing on it. So some bits, if you try to remove that, some bits of stone are falling out. So they don't know what strategy to take, either to remove it or do something.
Ivy, yeah. It depends if the ivy's on the surface of the wall or if it's going through it. If it's on the surface, it's not necessarily a problem, and actually ivy can keep walls quite dry. If it's going through it, and I think that's possibly what you might be mentioning, that obviously the root things gradually grow and they can fracture and distort. And there is also a weight question. So you have quite a lot of weight hanging off the wall. Yeah, I think there's a discussion there. It's up to you, I have to say. It may be that the ivy's just got too big and is going to result in distortion and potential damage and collapse. If it's I'd be very hard to say without actually seeing it, to be quite honest.
We do also have some publications on it. Not that they might not be appropriate for your case, and you might actually need to get someone out to look at it. But we have an informed guide on vegetation growth and an all technical advice note that we will try to link down there. So it might give you an idea what to look out for. And similarly, very quickly, we had another question about salt on lath plaster, and they are asking how to establish what the issue is. And again, we're going to link the maintaining your home short guide. I think that, again, that might give you an idea, and also the damp issues, just to have a first step to look at what that might be, and then you might need to get someone out. I don't know if Roger wants to add anything, but we might need to move on.
Yeah, no, I think you're quite right. I think the fact that you've got the salts coming through suggests there's active liquid water in there somewhere. And again, look behind it. We've got a couple of other questions more applied about the insulation. So let's, Lila, why don't you press on with that, and then we can always come back to those.
Yes.
Okay, I'll shut up.
Okay, so we have received, of course, a lot of questions about the best options to insulate traditional mass masonry walls. And just to start by saying that obviously external wall installation makes more sense from a physical point of view, but it's hard to do in traditional buildings and there may be statutory constraints. We are trying to do a few case studies, and we have done one at the South Hand or House Hand, sorry, I always confuse that, which we will link if you want to look at it. But generally here we will be talking about internal wall installation. So in the UK, wall installation generally is perceived as one of the main solutions, and a lot of energy performance certificates say that adding that will get you the desired EPC band, especially if you've covered all other measures except renewables. But even internally, there is a lot of expense and disruption. So wall installation in traditionally built properties is usually the last step, and should only be considered once all other energy efficiency measures have been adopted. But still, you can get a very good improvement on your thermal performance by insulating your walls. So a note here, if you're quite knowledgeable about heat transfer and U values, just to note here that we've done quite a lot of testing, and it appears that the average U values of uninsulated masonry walls are actually much lower, so they're better performing than what the standard calculation sort of software or the standard calculation results that you get. So it is accepted, however, that some improvement is necessary to your walls, especially where there are larger areas of masonry or where your walls are exposed, such as end of terraces or gable ends of detached properties where there are no window openings. So I will start by showing the first image. So just to say that there are various options for wall insulation. It can be inserted behind the existing lath and plaster linings. It can be applied to the existing linings. It can be applied directly to the mass masonry walls or to the plaster, or it can be held in place by timber framing. So the choice of what you go down with will largely depend on the makeup of your wall, existing wall linings, but also what your desired level is in terms of improvement. There's also a great range of materials out there, from natural products to foam to recycled, engineer, etc. But generally, the main thing is, as we talked about, and we always talk in all of our lives, is about breathability. So when you choose a material and approach, always bear in mind that an appropriate, a vapor permeable material should be used to avoid creating a vapor barrier, which could then lead to increased level of moistures and associated decay of either masonry or mortar or timber within a wall. So materials generally such as hemp or wood fiber boards are quite good. We use them a lot. Also blown cellulose or calcium silicate boards, as well as an insulated lime plaster, they're more likely to achieve this sort of vapor permeability and that continue the action that traditionally built properties already do. Non-vapor permeable products such as phenolic foam or the backfoil insulation, while they might be thermally effective, we advise against them as they might not be appropriate for traditional buildings, because again, they could lead to moisture concentration and subsequent fabric decay. Also, we strive to use naturally derived compostable materials if possible, as part of a sort of circular economy directive and to reduce waste. So if there is existing lath and plaster linings, it is usually best and less disruptive to use a blown or injected or sprayed material that would sit behind the lath and plaster linings, allowing the retention. And that is what you actually see in that photo. So there are holes drilled into the lath and plaster, and you pour the material depending on the product. There might be slightly different methods, but generally that's how you go about it. And the material sits behind the lath and plaster linings. This can be blown cellulose, which effectively, the cellulose fiber is like newspaper that's been shredded. We've used polystyrene beads, and also we will talk a little bit about open cell foam a little bit later. So these options are good for when you have small gaps and can be used when you already have plasterboard as well. And we've trialed them in quite a few Historic Environment Scotland projects. And what you see in that photo is actually from Hollywood Park Lodge. We've spoke about it before, and we have used the cellulose fiber, which, as I said, the shredded newspaper. The air gap here behind the lath and plaster was 38 millimeters, quite thin. And as I said, that's why these products are quite appropriate for when you don't have a big air gap. You still need, if you have a very small gap like here, you still need to do drill a few holes. So it can be a little bit disruptive, but it's way less disruptive than other methods, and it allows you to keep your linings. We had a lot of questions about open cell foam, so we cannot not mention it. We have trialed it in one of our refurbishment case study, that is Anna Road case study 20. We will link it down there at the chat box. And to say, we have only used it on walls, not on roofs or floors. And we generally taken the approach of maintaining the airflow throughout the building, so that's why we've only concentrated on the walls. And just also to say that there are two types of it, like the open and closed. We have only tried the open cell foam because, again, that ties in with the whole sort of vapor open approach that we take. And again, I mean, that's a separate discussion. We can take it offline, but we generally now try to go away from these materials and use more naturally derived, or, as I said, compostable materials. So when you're installating behind the lath and plaster walls, just bear in mind that it is reducing your air gap, so there is reduction of ventilation. So it's very important as part of this solution to actually make sure that the wall remains vapor open and capillary active. So make sure that your masonry wall is dry and there are no signs of leaks or any dampness or anything like that. And when you have any excuse me. So when there are any concerns over existing, sort of, when you have any intervention, you might have concerns about interventions to the void behind the lath and plaster. So adding a thin layer of insulation onto the lath and plaster wall may be appropriate in some cases. So HAS has used aerogel-based products in a few of our case studies, which have been applied onto the lath and plaster. And this allows the air gap behind the lath and plaster to continue to function as was unchanged. These products, the aerogel-based products, come as boards or blankets, and they can be supplied as roll or as a board or a blanket. It can be plastered on the top, so you can continue after that and just finish your wall as you would. And there are also other materials too, either blown or in a rigid form, such as boards, for when you don't have any linings or not the original ones, and you have sort of bare walls. So when you go down this approach, you will probably need to fix this board on a timber strapping or framing to the masonry to hold this board-based installation materials, as you see here in the photo. So again, there are some well-established materials such as hemp and wood fiber board that we have trialed. These are thicker, so you might need the sort of a proper framing. But we use them a lot and they work well. The material is placed within the framing and it can be finished with either plasterboard or clayboard. It is important here to know that if plasterboard is being used, this should not have a foil back or other integrated vapor barrier or vapor control layer, as such material again will sort of stop or hinder the movement of moisture through through this makeup, the assembly. If you also have rubble walls that are unplastered or were originally plastered on the hard, a good option is to replicate that, so to replace with insulated lime plaster. This is, you get one material with everything, your installation and your finish. So basically you mix the installation material with the lime plaster, And you can do that. You can buy pre-mixed or you can mix it on the spot. And here you see that image is from a case study down in Cottage. I think it's refurbishment case study 22, if I'm not mistaken. You can also use other products like this calcium silicate board, which you will see on the next image. This is in that image is applied directly on the plaster walls. But generally, wood fiber-based products and other vapor-permeable materials can also be directly fastened on the walls as well. Last but not least, I spoke a little bit about like cellulose fiber, which you will see in the next image as well. This has been sprayed on a wall that didn't have any linings, so it's been you have the vertical timber studs that are fixed onto the wall, and you spray the material in a wet form between the framing. And again, it can be covered up, as we spoke about, either with a simple plasterboard, or you can do the whole thing if you'd like to. So I'm going to stop here because I think I've taken a bit of time, and we'll get to the questions as they might be more helpful and more specific to you. So I'll bring Roger back in. Hello, Roger.
Oh, yeah. Right, I'm just scanning through the chat just to get a feel for the nature of the questions. I think we're probably going to deal with isonine and all that stuff perhaps in a later session. Yeah, I mean, quite a lot of it about this gap business. I'll just reiterate: if you have a wet wall, you won't be filling it with anything. In fact, you'll have rotting timber as it is. This relies on a wall working properly, and indeed, sometimes that lining is taken off, and new material is put on, and there's no gap either. There was a note in the chat about a void being required by building regulations. That's not strictly true. We ran our guide past Building Standards Division, and they're very happy with traditional buildings, firstly as they are, and secondly with the range of options. But you've got to make sure that your structure is working properly. So we give a range of options that you apply in the circumstances that suits you. And for that reason, we can't really get into a huge amount of detail. But let's take some questions. Let's have a go anyway. Where do we start?
So I will start, I think, with the ones that we received as an email, because as a priority, I guess. So a very general question about the house being dry lined on the interior walls, probably the 1980s, but it's very drafty. How can we draft proof this? So we can't cover this now. That's from Jane over Facebook. But we will link you to our energy retrofit short guide down there. And if you do have any specific questions after this, we can take it offline via email.
Yeah, I mean, for Jane there, if you've got a modern lining that doesn't seem to be helping you at all, you've got lots of options. Maybe an insulated lime plaster. That's quite a very durable sort of basic measure. We've tried that in a couple of places now. So I think have a look at our new retrofit guide and have a look through what's available to you. If you've got modern internal linings, I'd say you have quite a bit of flexibility.
A question about planning permission. They could not get planning permission unless they installed a timber structure and left a cavity between the insulation and the stone. Is this necessary? How is the air moving around a 60mm air gap without forced fans and ducting?
Yeah, that's getting a bit... I mean, this depends on your local building control officer, and I'm afraid many local building control officers look in the approved details and take their solution from that. But the thing with that is it's not the only remedial measure that you can do. You can do whatever measure you can propose as long as you can support it. So a lot of this depends on an inconsistent approach by building control officers. And again, our retrofit guide shows a range of options that we've run past Building Standards Division. I do also accept there is a need for some sort of local education campaign with building control as well, because that's quite often inhibiting appropriate solutions. And quite often, frankly, I'll say it, some standard solutions are actually actively damaging to older buildings.
And that actually covers two questions that we received that are similar about the air gap being insulated without being detrimental to the building. For sandstone and granite buildings, please look at our retrofit guide. And another question about passing planning permission. So again, look at our retrofit guide, but we will try to have another publication called Guide for Practitioners, which will be hopefully published in the next year or two, which will address more the building issue.
And remember, planning permission and building control are two very different processes. So, okay, yeah, definitely work in progress there, clearly.
So is it advisable to use open cell foam on a cement pointed wall? Does this change if the internal linings are lined plasterboard? Do you want to answer this now, or shall we do that in another session?
It rather depends what that foam actually is, doesn't it? Internal linings are lined plasterboard. What does lined plasterboard mean? You mean foil backed? If that's foil backed, I think the answers are no for that, because it's academic, because the plasterboard is lined as well, and you've got a cement pointed wall. So I'd suggest that's a kind of, that's not a great moisture dispersal scenario, is it?
So I will get to the questions on the chat now. Let me just see. So about an external wall, again, repair with concrete mortar. Have you any tips for remortars? Going with lime mortar. Sorry.
Repair with the concrete mortar. Any tips? Well, yeah, I think a bit of guidance then. I would be going for a quicklime based mortar, possibly gauged with hydraulic to give it a little bit of a set. If you have a quicklime based mortar, it'll be more vapor open and more capillary active, and a hydraulic gauging will give you the necessary set. Try to keep the joints keep it as flush to the plane of the wall as you can, but again, without seeing it, it would be wrong of me to go into too much detail there. We've got a short guide on lime mortars. Which number is it? Short guide. Can't remember which short guide it is, which gives you the pros and cons. Which number was that?
I think anyway, it's 6. Yeah.
6. Yeah. No. So that gives you perhaps some thoughts and considerations on mortars. Lots of different worlds of discussion are opening up here, so we'll just have to deal with what we can.
Yeah, there's another question that goes about maintenance more. Lynn.Facebook asked that they live in a granite building, granite built croft house, which has been rendered on the gable wall, gable end, and the harling is now crumbling and falling off in small bits and leaving black mold beneath. So I wonder what rendering that is, and should we take it all off, and what can we do about the mold?
That's an interesting one. Getting mold behind external renders is very unusual. I haven't seen that. Maybe send us a photograph, but perhaps it implies there's quite a bit of moisture behind that render, hence the decay. And granite is not very forgiving. There's no vapor movement in it at all. So you may be seeing some quite strong results there. Maybe you're in the replacement business, but by all means send us a photograph and we'll happy to comment on that one.
Next question, Donald, Facebook. They would be very reluctant to create a bridge between the outer wall and the back of the internal wall. Is the movement of air not required to soak timber rod in the laths and studs?
Well, no and yes, depending on the condition of the wall. If the wall is dry, that won't happen. If the wall is wet, those studs and laths are rotting already. Almost definitely, and that happens very frequently with or without the attrition on the air gap. So again, it's back to the wall condition. The properties that we've done, they've been in good condition. the measures have been in, some of them have been in for over 10 years. So, the right building, the right situation, I'm comfortable. The wrong building, the wrong situation, no.
And to reiterate also about the choice of installation materials, because I take it you're talking about insulating the air gap. So it's about, again, the vapor open materials that allow this moisture.
Vinyl wallpaper is a good way of just sort of, again, it's one of those sort of accidental things you fall into, but actually that has potential consequences. Do I see one with a new build in 2006?
Yeah, Fiona on Facebook is asking, their house was built in 2006 and it's timber frame inside, but on the outside it's red sandstone reclaimed from an original derelict farmhouse. They have been told they should paint the gable with a non-permeable clear substance to waterproof it. It's extremely exposed, and they're concerned about creating an issue if they do that. They're also getting frost shearing on some of the sandstone.
Right. Well, very interesting question. I think what they're referring to is a silicon-based waterproofer, and we're tackled with this quite often. People talk to us about this, and we've got perhaps traditional materials and approaches to address this: pointing, renders, lime wash. So I'd be careful about that. Also, silicon applied liquids don't bridge gaps and cracks. They can't do that. So it doesn't really take away from your the condition of the stone, what it was pointed with originally when you had the house built, or indeed the detailing of your building. If you've got some frost damage on the sandstone, that suggests it's getting wet and it's staying wet. So there's perhaps a detailing issue here. My personal view is I don't think silicon water repellents have a place in traditional buildings necessarily, and we've got plenty of traditional options to deal with it, which I know work. So they're the ones I'll stick to. And to be fair, I'm not a good fella on modern buildings, really. I can't see the situation, so probably have to kind of leave it a wee bit like that.
So we only have a few minutes. We can maybe go past for 5 minutes, but I'm gonna go very quickly through some of them just to acknowledge them. We had another question by Charlotte about the cavity wall insulation, creating a bridge between in and out of brick skins. Is cavity wall insulation always to be avoided? Again, we've covered that before. We had a few questions.
Yeah, I noticed late 18th century brick built. Yeah, so perhaps not a typology I'm familiar with on there.
But I think general principles still apply. We had a lot of questions about where people can buy materials from and if we have a list of suppliers. So unfortunately, we don't have such lists. It's very hard to keep up with new products and tradesmen. Also, as a public body, we can't recommend anyone specifically. But if you're struggling to find someone locally, we might know a name. So drop us an email.
Perhaps quite a good contact for people is the Association of Environmentally Conscious Builders, AECB, and they've got quite a good retrofit approach as well, which is sort of similar to our approach. That might be of use, and I think they have supplier information and things there.
That's great. So look on Facebook, he's using wood fiber boards for internal wall insulation, and again they're asking if they should leave a gap between the board and the ground floor to stop moisture wicking up.
Wood fiber water. Well, again, I really hope you don't have liquid water on the bottom of your wall inside your house. I mean, that's not a situation. In any event, the wood fiber boards for internal would actually sit on the floorboards, which I'm hoping is above the solum, which should be dry anyway. So no, I mean, wicking up means liquid moisture. You'd be in a very bad place if you had liquid moisture being drawn up on your internal wall insulation boards.
Right, we're gonna take 3 more questions that have come in, and then we'll have to kind of stop there. quick question about the spray cork insulation now available. What do we think of it?
Spray cork. So cork is quite a good insulation material. The question is what it's mixed with, and I suspect that could well be in a lime matrix, possibly blown on with a Harling gun, maybe, which I know many people do for external lime renders already, actually. So don't know, haven't used it, haven't tried it, but cork is a good insulation material. Do I see something about Latham?
Yes, would a blown insulation between wall and lath plaster not just fall out the bottom to below the floor?
No, because you take the skirtings off and you close that gap with the on the stop line, the timber brander, with you pack in the cellulose or whatever material it is. In fact, we used a little line of sheep's wool to close that gap, so the floor, as you say, the floor solum would otherwise fill up.
And I think that's going to be maybe the last question. Sorry, given the symbiotic nature of solid walls, is there a better time of year for upgrading works regarding drying out to minimize effects on internal finishes?
A better time of year. Yeah, I mean, a bit of ambient temperature helps, doesn't it? In the winter, the air is often very dry, so sometimes things will dry out very effectively. Spring about now is a very good time for a lot of work. You've got just enough temperature, but not too much direct. Is it a better time for upgrading works? Re-drying out. I mean, I think most people will be restricted by budget and what their operational circumstances are, but spring is a good time for construction work generally.
And just generally, sorry, we had a few questions about the air gap. So if Roger, you just want to reiterate just the finishing line before we close the session today.
Yeah, well, as I said, we can suggest a lot of options, and you need to work from the outside in, and the outside needs to be working properly. But in our experience, it works fine. Not everyone will need to do that. A lot of people will have plasterboard walls or damaged walls on the inside, and therefore you've got an open a much more flexibility. But if you have historic plaster linings and you wish to keep those, we can just suggest a couple of ways by which you can achieve that, and we've described that in a couple of in the retrofit guide. We've written about it in many case studies, refurbishment case studies over many years, and so you don't have to wade through those. Technical paper 24 gives a summary of the work that we've been done. We've tried various materials. We've tried polystyrene bonded beads. There's the foam option, and there's the blown cellulose, and there will be, I'm sure there'll be many more coming down the line. But I must emphasize it's the condition of the internal face and the external face, and the water loading on that wall and where it sits that's really the most important characteristic.
Great. Sorry.
Any more?
No, it was just also to say about that question about what time of year to do the upgrade of works, or what kind of weather. It's just to say that it's not so much about the upgrade works, but if you're talking about maintenance, especially like line pointing, then yeah, it's better to do when I think it's like overcast, not too dry or too hot or not too cold either.
Yeah, there's a certain sweet spot with lime, and you can do lime in the winter. I've been on projects where we've rebuilt chimneys in the winter, and they've been fine, but it's being canny about what you're doing, and basically new lime and lots of rain is a really bad thing, and that doesn't work, and new lime and hard frost doesn't work either. So you need to make protections accordingly, or judge your weather windows. Right now, the weather's clear and bright and actually quite dry. So your lime now is at risk of drying out too quickly, of actually just cracking and not carbonating properly. So it's understanding what your materials are going to be doing and what the weather that you've got now or in the next week or so, what that's going to do and how that's going to work. But as Leela said, for a lot of lime work, a warm, slightly overcast, almost damp conditions is really good for external harling and rendering work, because you don't want that to dry out too quickly. You need to get a few days to get the set, and then within a week or so it should have done its sort of carbonation and really started to cure nicely. But I did a harling job. I did a harling job in Dundee in 2001 in January in the snow, and that property in Dundee looks as shiny and new as it did when it was put on. Partly because Dundee's warm and sunny, and it's very sheltered, so we got away with it. But we kind of knew what we were doing.
So I think we're going to stop here because we have gone a bit past our usual time. Just to say also, we have received 1 or 2 questions that were very technical, very specific also to software, sort of hydrothermal software like Woofy and quite technical ones that we will either reply to you'll ask you to email us at technicalresearch@hes.scot, or if it's something that's relevant to the next session, which will actually be about micro-renewables in the historic environment. And they might be more relevant to that session. So please tune in for that one. I hope you find it useful. I won't be there for the next session, but our colleague Kenny Easton will be joining us to answer all of your questions on micro-renewables. And there might be a little bit of a chat around maybe EPC, so it will be a good one.
Yeah, EPC is a really interesting topic where there's a lot of variation in interpretation, understanding, and application. Yes.
So I'd like to thank Roger again for answering all these questions. We got a lot of them today, so apologies if we didn't get through all of them. And just to let you know as well, we have a feedback survey, which my colleagues are going to pop down in the chat box, and we will ask you for also ideas and suggestions for next future streams. So I'd like to thank Roger again, and we hope you enjoyed this. Thank you very much for tuning in. And as I said, if you have a question, please email us. And thank you very much for joining us, and enjoy the rest of your day.
Cheers.
Goodbye.